Somebody's sitting there already, right? Yes.
That's fine. I can explain it. That's the that was because I was spinning.
The organizers sit there for some reason, but I think it's all right to sit there. They're trying to move somewhere else. Romney's big game. Right?
Yeah, they are. All that mechanism.
Talk bad about it.
I don't like coming downtown unless there's something I'm really interested in. I don't bother. It's kind of an ordeal. Yeah. I got my Bluetooth and iPad talking as of last night. Oh, cool. So finally I got the other protocol ripped out and put in a new one. I rewrote it because a lot of that stuff I did back when I was just learning. I ripped a lot of it out. But last night I finally got like full bandwidth.
Brad? Brad. You see him?
And the reason I chose that, I guess Microchip has one that supposedly has the ability to just boot up and act like a serial evolution modem, but I didn't have any code space left, or very, very little code space. And one of the things, Giga has a scripted way. Yeah. And kind of like base. It's almost, it is basically. Yeah. It's an event-driven basis. Right. And so sit there and nothing taking up power. If you don't use that scripting language for development of API modules, you buy like this $3,000 IAR development environment. And so, but they have the scripting language. It's really slow. It's slow, but fast enough to do what it needs. Power profile where you can watch your power profile, so you can watch it on like what you use in their little IDE, and when you see a power spike or something, over that, they blink their power graph.
Design guy.
Is that built into the module or is it part of the development?
That's part of the idea. One thing I've taken on the actual development board, I haven't really been in on the box.
Yeah, that's why I was asking. I don't remember. I don't have any. I mean, I don't have any kind of really development environment. I have a text editor and a download and a compiler. I'm not sure.
Yeah, I got it's part of the rocket. They got the rocket demo board, the rocket board. It has that part on it.
Radar.
Well, the rocket, they showed it off.
I mean, I had lots of things talking
Before they announced them, before that they had the round cup.
Okay, did I get Silicon Labs or somebody else because I can get Silicon Labs? But the rocket thing,
Because the scripting language is amazing.
the BTS,
Yeah.
just nothing you say is ringing a bell at all. Okay, it's weird.
It's fun. I'll tell you.
Everybody wants to contribute something. But I gotta say,
That's the demo board that has this on there and their it's just a contest, but it's real so fun.
this is not, because I bought a development kit, there's a board, and he had various different modules that you plug into, and you had all these different sensors, and no, it was a development board with a built-in debugger. And
A little screen on it.
a little screen.
Yeah, so that's the Gecko development.
Right.
Yeah, I got that too. They've got, well, I'll send you the what I've got. We're using the same part, it's a scripting language.
Yeah, I mean, they have the scripting language on all their parts. It's just, like you said, it's just weird. I'm not doubting it. One of those things that's weird that I can't think of the words you're saying in my perusal, and I've been watching videos and reading documents and stuff. It doesn't come up. Oh, I made it. I made a really stupid mistake without. I just didn't really think about it. I designed it as a 1/3. And I go, oh, that's a newer one, slightly lower power, it'll be great. And I got to my board on the part, and I realized that you can't hand solder. It doesn't have any exposed pins. It's like the module, all the pads are underneath the module. And it's like, and I made one attempt to solder it down, and I put through it, and I redesigned the board. It was a few hours redesign, and I ordered more boards. Put in the BL112, BLE112, which has like no, I read that. I had only looked at really carefully looked at the 112, and I didn't stupid. I didn't think about it. I thought, oh yeah, that'll be easy.
Hey guys, welcome. There's still plenty of pizza left, and there's still some chairs up here. If you guys want a better view of the festivities. My name is David Endler. I'm the volunteer organizer for this group, and this group and this meetup would not be possible without Capital Factory, who provides a venue, and by generous sponsors like ANSYS, who is sponsoring tonight's meetup and providing all the food and pizza. So you'll hear from them later, but quick round of applause for those guys. Thanks. So, quick show of hands, how many of you, is this your first time to this meetup? Awesome, welcome. How many of you is this your first time to any meetup? Oh, thank you for coming and taking a chance on our meetup. So for most of you who are new, this is a group, it's a very eclectic group of people who are interested in launching hardware products. There's a great mix of hardware hackers, business development, sales and marketing, and entrepreneurial talent in this room. Sorry, one more survey. By show of hands, how many of you are actively launching a product, a hardware product right now? Whether it's concept, design, oh, awesome. So part of what makes Austin great is our sense of community. We may not be San Francisco or New York or some of the other areas in the US that might have a bigger hardware presence. Boston, yeah. But what we do have is a great sense of community. And so through groups like this, we hope that you can connect with each other, learn from each other, and even though we meet once a month, we have a mailing list. So this is, I've heard from many of the people who come from out of town that our mailing list is one of the most active and helpful of all the meetup groups. So if you didn't really get to meet someone you wanted to talk to a little bit more, you can reach out through meetup.com or through the mailing list. So the format is pretty standard. We meet third Thursday of every month here, and we offer a chance, if you're working on something cool but you're not quite ready to present it in full, to do a demo. A demo can be very informal. We have one tonight. And it's just a chance to tell people what you're working on and get some feedback from the audience, which is really helpful. And then kind of when you're ready, come back and present it to the whole group. We usually have one or two main speakers, and then at the end, we have an open mic where we just let people come up, introduce themselves if they're new to the area, or if you're looking for a job, if you're hiring, really anything pertinent to the hardware movement. So without further ado, let's get started on our demo tonight. I'd like to introduce Jeremiah Wagstaff, who is, has quite an eclectic background, graduate of A&M and 8-year veteran of the Army infantry officer, so thank you for your service.
Thank you.
And he's also the founder of OmniBuilds, which he's going to tell you a little bit more about. Apologies, my laptop is not connected to the internet, so his demo would have been even more awesome if I could have allowed him to show the site, but I encourage you to look at omnibuilds.com while he's chatting with you. So give a hand to Jeremiah.
Thanks, everybody. I'm just going to speak. It's easier. I'm here tonight to talk to you about a website that we're getting ready to launch, which is called OmniBuilds, omnibuilds.com with an S. We were going to do a demo, but that's okay. We can just talk about it. And I'll be giving a demo at my laptop afterwards if anybody wants to come by and get a look. And we're also going to be giving a much longer presentation at Tech Shop next week, Tuesday night at 6:30 at the Tech Shop up in Round Rock. So basically, OmniBuilds is a website for hosting and collaborating on hardware projects that you could compare to GitHub for hardware. What it allows you to do is to track all of your design files, a bill of materials, and all of your documentation in a version-controlled repository that can be shared with anyone. So let me break that down a little bit more. So the reason that we created it was basically to make it very, very simple to track a hardware design or hardware project, to track all aspects of that project, and then collaborate on that with anyone that you want to. And hardware is defined loosely, not in terms of just electronics or PCBs, but very loosely in terms of any type of physical object that you could manufacture, fabricate, or build. So the way that it works is it tracks all of your design files. So you can upload CAD if you want in any type of format, PCB, you can upload your Gerber, you can upload mechanical CAD, you can upload drawings if you have those, or you don't even have to upload CAD, you can just give it descriptive data and upload some images. If you need to, you can link it to a website. You can just give it properties for any given part. And then it takes those parts, which have those CAD files with those properties associated with them, and then it organizes that into a nestable bill of materials. You can have basically assemblies within your bill of materials. And the bill of materials tracks those files and then, or those objects, and then it also, in the kind of layout of it, it's just a table view, so you get to see the quantity and the price of everything you've got in there. And each one of these repositories, so this would be like a design repository for something, like let's say like a Raspberry Pi case. It has like a 3D printed bottom, a 3D printed top, a Raspberry Pi, and then it's got some screws, some screws to mount the Pi to the bottom, and then some more screws to mount the two together. So each one of those would be a part, right, in the bill of materials, and each one is also its own repository as well. And I say a repository kind of in the same language that we use in Git in the software world, that it is an actual repository that stores all aspects of it, all the files, and it is versioned. So it's fully version controlled, supports all the revision history, and you can, it supports Git style workflows, so if you want to branch or have like variants or alternate configurations of your design, you can do that as well. So it tracks all of that into a bill of materials, and then that bill of materials is nested, so you can drill down into it and see other parts. And then if you were to drill down in like a CAD file, you would get a rendering of the CAD file in the browser, the 3D view, or whatever type of file that you have. And then from that bill of materials, you get basically a price or an estimated price of what it would take to produce it. And right now, all that data is user input, but the goal is to connect that to pricing and sourcing APIs, so you can see real time what the cost of those parts were. Once you have your bill of materials, it's very easy to generate documentation based off of that. You can either upload your own documentation files if you already have them, and they're versioned as well, or you can generate documentation off of your bill of materials, off the parts in your bill of materials. So you can say, like if you've ever used Instructables, it's kind of similar to that. You can create a step, you import some parts from your bill of materials, and then you give a description, you can upload pictures, and do whatever you want to document how to create that part. So that's the basis of it. You've got design files, you've got your bill of materials, and you've got your documentation. And then on top of that, it's also collaborative. So it has kind of two types of repositories. You have public and private, kind of like GitHub. So public repositories are open source, so this is kind of geared towards the open source hardware, kind of hobbyist, maker, hacker movement to start with. So anything that is open source is by default free and public and anyone can use it. But that doesn't necessarily mean they can edit it, they can just see it, right? You'd have to be a member of the team on the repository to actually edit the design. And so there's this notion of a team, and you can import or you can add other users, give control their permissions, but you can also fork a design. So if you see a design that you like, but you're not on the team, you can fork it, and then you can do what you want with it. And then on the private side, and that's the paid feature, then you can have these repositories basically behind a firewall so that they're not out there for the public to see. And you can also have private organizations so that you can control multiple designs and share access between different users. You can also have public organizations. So if you wanted to have an organization for like a makerspace or a hackerspace or open source hardware community like Raspberry Pi or FarmBot or something like that, you could do that as well. And then you could kind of organize your community or collaborate much easier with your community on the site. So I think I'm pretty close to my 5 minutes, but let me just say, again, we're going to be at Tech Shop Tuesday night, so it's up in Round Rock at 6:30. If you'd like to come by, probably need more like a 2-hour talk, about an hour demo and an hour discussion. The site is not live yet. It will be launching soon. You can go to the website right now and just sign up to get notified when it goes live. And also you can come by and say hello, and I'll show you what I got right now. So thanks for your time.
Is this a cost model, or is this, how are you finding it?
It's a subscription-based model, so basically it's per month. So right now what we're looking at is $10 a month for individual repositories on the private side, and that would be just individual, so you couldn't necessarily collaborate with others, but you could share. You could give people like view access to your private repository, and then it's probably going to be in the neighborhood of $30 a month for a team or an organization. That would be about 5 users, and then there would be an additional probably $15 a month per user after that.
And there's going to be an open source component of it.
The open source, right, that's actually what we're starting with, is just the open source version. So, and that's totally public, totally free, unlimited repositories, unlimited collaboration. And then soon thereafter, we're gonna launch the individual plan and then the organizational private plan.
What is soon thereafter?
As soon as I finish coding.
Is it organized as a drawing tree, or is it just a bunch of nested bombs, like a bunch of lists?
You mean in terms of like the UI?
Sure.
Okay, so it's
I'm
organized.
trying to get a feel for how design files and bombs are shown. You
Okay.
know, one way to do it is to list the design files in the bomb.
Mhm.
The other way is to have them be at the same
It
level.
actually supports it either way. It's up to you how you want to do it. So you can actually have multiple design files attached to any given part, but the way it's designed to be modular. So if you actually have a one-to-one relationship between your design files and your parts, it makes it much easier for other users to import parts that are in the public library and just import that part and not the whole design. But it's not, there's not like a strict typing on how the user creates that, if that makes sense. Now, I'll show you afterwards.
Okay.
Yes, sir.
Your bill of materials, is your intention to also manage multiple sourcings, which includes, the manufacturer, where you purchase, the distributor, the local rep, all that?
Long term, yes, not that long. Right, in a couple years, hopefully.
How does it compare to like an arena or fishbowl, inventory, or not, inventory bomb management type
Right.
of side of those two?
Yeah, so like Arena PLM is a great tool for product lifecycle management, and I'm familiar with how that works. Right now, it's not as feature rich as something like that. I will say it has a much more friendly user interface, and it's much more collaborative from the start. That we will be getting to something like that before we launch an organizational plan. But if you were to compare it to like a Thingiverse or an Instructables or a GrabCAD or something like that, it's way, way better.
What's, like, if you had to say, you have no ETA on this, we're kind of up against the wall and have to make a decision, on a platform, but it sounds awesome, so,
Thank you.
no ETA on when a release might happen.
I mean, I think there's gonna be a public release in the next few weeks, and then probably within a quarter or two, there'll be the other options available.
Sure.
So it's gonna be maybe by the end of the year.
Okay.
Anyone else? Okay, thanks a lot. Thanks, Dave.
testers, obviously, it sounds like you have
Yes.
more than enough.
We do need beta testers, actually.
So if you drop an email on the list too, I'm sure you'll get
Yeah.
more than enough support. Great. Our next speaker is Bailey Jones. He is the founder of Bright Product Development, and he's an industry veteran. He's worked at such places as Dell, Oakley, 3D Systems, and he's compiling some of his knowledge into a book with some war stories. And the title of the book,
Startup Guide to Making It, Manufacturing in a Maker's World.
and that link is actually in the description of our meetup if you want to check it out. Give a warm welcome to Bailey. Oh, yeah.
1 second. So it's kind of, okay. Got it. All right, hi. So I'm Bailey Jones. I work at Bright Product Development. And actually, interesting thing, I got involved with this group, it must have been 4 or 5 years ago, right here in the Capitol Factory, and I gave like one of the second or third talks. I think we were back in a conference room over here. But yeah, we quickly outgrew that space, so this is really great to be in here again. I'm going to be talking tonight about things that I do pretty much every day for work, and that's design for manufacturing. And we're talking about, let's just take a specific example, starting with a PCB. I'm going to be talking on the things that would go on the outside of that. So maybe you've got a case of some kind, could be made by any variety of manufacturing methods, could be of any variety of materials, likely plastic, and maybe have some moving parts, buttons or anything like that. And also thinking about a view for producing in some sort of quantity, right? So when we talk about producing in quantity, we want to use established manufacturing methods. We could think about molding, that includes injection molding, of course, and other kinds of molding. We've got extrusions, could be plastic or metals. How about forming? Sheet metal parts are formed. Any variety of fabrication techniques are used to form metals. And how about 3D printing? We've got a variety of different manufacturing methods, and each one of those are going to have specific kind of design criteria. If you're designing a part for 3D printing, it's going to be quite different from a part that you're designing for, let's say, injection molding. So we're going to talk a little bit about the specifics of some of those. Let me start just with an example. I'm going to try to handle both my things here in the mic. I might have to drop the mic at some point. But just as a way of introduction, in fact, I'm going to drop it right now for just a second. As a way of introduction, we've got a case here, okay? It's a plastic case made of 3 plastic parts. This is a surgery kit for a surgeon for an implantable hearing aid. At any rate, we produced this case. I worked on this a number of years ago with engineering and design. You've got an inexpensive plastic parts on the top. These are about $2. These small pieces on top, and the bottom piece a little over $3. So in order to produce a nice looking part efficiently, and by efficiently I mean cheap, right? We want our parts to be inexpensive. We've got to pony up at the beginning for some sort of tooling. In this case, the tooling is injection molding tooling. We're talking about big blocks of steel that are manufactured specifically for these parts that go in an injection molding machine. And for this, we're looking at a price of $35,000. $35,000 for the tooling for this case. So immediately we start thinking of things. The price becomes related, and manufacturing method becomes related to volumes that you can produce in, right? So if we want to make 10 of these, if we want to make 100, we're not doing this. If we want to make 100,000, yes, thousands, maybe, it depends. So we're going to get a little bit more into the specifics of this, but this is just to show that volumes and price are closely related to manufacturing method.
that now with 3D printing and metal printing and stuff?
It gives you some more flexibility. We'll talk about some specifics a little later. So now let's take a little bit bigger picture view here, and I want to look briefly at timing. I'm not going to cover everything that goes into timing, but we'll talk about a couple of points that are often underestimated. So that second line item, and by the way, we're not going to talk about all of these, but can we make this available at some point to the group so you'll have access to this? Finding and vetting manufacturers. I've got 8 to 12 weeks there, which may seem like a lot. There's a few good ways to find and vet. Maybe some of you have been through this, and I'd like to hear your comments on this. There are some good ways to find manufacturers. One good one, especially for us, is to harness the power of this group. I've known of several connections through here where they've succeeded in having good manufacturing partners. Another way to do it is to hire we'll call them a production team. And they'll take your drawings, your models, and they'll quote a variety of contract manufacturers and go through a strong vetting system for you. One thing that I have not seen much success with is looking on the internet and choosing somebody. Maybe we're going to change that with something like the Omni builds or something like that. There's other people that are working in this space, so it's probably coming, but I don't think we're there yet. The main thing being is that having a successful manufacturing partner comes down to having a good relationship, whether we're talking here in the United States or we're talking overseas. You really have to put the time and energy and money into having a good relationship. And by the way, you're up against other companies that may or may not have more resources to you that make them have some good status, or it takes effort to have that relationship, and that's part of the manufacturing deal there. Another item there is a tooling manufacturer. We touched on tooling just a little bit a while ago. Not so long ago, we used to say it takes 12 weeks to get tooling. That was just the standard answer, and it was standard in practice as well. Nowadays, it can be quicker than that. But you will want to give, I've got 6 to 12 weeks listed there. You do want to give a good amount of time for that. If you're part of a large company that has an established relationship with manufacturing, you can probably squeeze that down some. If you do not have those things in place, you're going to be waiting to get on the schedule. You're going to be waiting for various things, and it really does take that long. And by the way, there's also going to be some changes to the tooling as well. You're going to go through kind of iterations with your tooling and possibly or probably adjustments to the tool. So I just wanted to touch on those two. Obviously, there's a lot of things that go into timing. And oh, by the way, did I mention, we're talking 18 months to deliver a physical consumer product. If you want to be really optimistic, you might say 12 to 18 months. You're going to have the temptation to try to forecast a tighter schedule than that. I would caution against it. It takes a long time.
I mean, beam up to the enterprise and make it on the replicator.
Sure, sure. Okay, now let's circle back a little bit and talk about some of these specific manufacturing methods. I want to give some examples, kind of representative examples of different manufacturing techniques. So back to injection molding again, just a cheap throwaway pair of sunglasses. Tooling, I got a quote a number of years ago, tooling for just the front frame part, not the earpieces, coming in at, what is it, about $12,000 with a piece price of 27 cents. So that's another example of putting your money in up front and getting cheap, nice looking parts out. Let's look and see what else we got here. Extrusions. I like extrusions a lot. This extrusion is a case for a PCB. It's a diagnostic tool. It's about this long, maybe about 4.5 inches long. You can see some notches there where the PCB would slide in. And you've got an injection molded cap that screws on each end. Tooling price, a little over $1,000. That's great when you're producing in smaller quantities. So extrusions are a sometimes overlooked manufacturing method. You can get some really nice parts. The piece price on that was about $4.50, and the production quantity was in the thousands. So that'll give you a reference point for extrusions. Prices might have gone up a little bit in the past few years, but still significantly lower than injection molding. Here's a bracket. This bracket here. It's sheet metal produced by forming, and you'll see that I've written up there that there is no tooling required to produce this part. There's several things that go into that. One, it's got straight bends. It was designed so that it could be produced without tooling. This part comes in at about $4, I think. And on this piece of furniture that this part went on, there's 6 of them, so that's $24 already. If we use our rule of thumb of multiplying that by 4 or possibly 5 to get a retail price, we're at $100 already, which might be hard to swallow for this piece of furniture. It is possible to produce sheet metal without tooling, and it's also great because you can prototype it, possibly, without tooling. Of course, if you're making 10 or 15, your price is going to be a lot more than $4 a piece. If you are transitioning into a higher volume manufacturing scenario, you can produce this with tooling. There's a kind of system where you've got slides coming in that get all the different angles, and you can pretty much form this piece in one go. The tooling for that can rival the price of injection molding, probably somewhat less, but still you're putting down the money for that, and you're getting cheap parts, though it'll probably be less than $1 in that case.
When is the break point between when plastic becomes less expensive?
It's different on every project. And that's part of the challenge and fun, honestly, to determine, what manufacturing method is right for your project and what material is right.
Because Apple chose metal on a lot of their products.
I could
it's
talk.
a significant cost.
I could talk about that for probably a long time. Maybe we'll get into it towards the end of the presentation. I want to talk more about the specifics of injection molding and designing for injection molding. Like I say, designing for injection molding is very much different than designing for 3D printing. This is a pretty typical kind of example of an injection molded part. If you can't see it, you can come check it out later, or maybe I'll pass it around here in a second. Basically cup shaped, right? With a more or less rectangular cross section. This is going to be 1/2 of a case for a PCB. Very standard kind of shape. If you look closely, or if you look very closely, you'll see that those vertical walls, that rectangle cross section is not actually rectangular. Those vertical walls go out at an angle. That's a very important principle for injection molded parts. If we make an analogy of a sandcastle, we have the walls of this form angled so that the mold can slip off of the sand, right? It's the same thing with injection molding, and we call that the draft angle. Every vertical wall on an injection molded part will be drafted, anywhere from like less than a degree to several degrees of draft, and that's going to be a critical component. So that's one item. Another thing that's important and lends itself to that kind of cup shape is the uniform wall thickness. You could imagine we could have that part be solid on the inside, and then there would be a lot of material. It's also going to create a lot of problems in manufacturing, but the price of an injection molded part comes back to the volume of the material. So that's one reason. Secondly, we want to dissipate heat in these parts, in these hot parts as they come out of the tool as quickly as possible, and we want to dissipate the heat in an even, homogeneous way. So for that reason, we'll have a uniform wall thickness. If there are masses of material, they will retain heat and they will result in imperfections in the part. So that's two items. You've got draft, you've got uniform wall thickness. Speaking of deformations in the part, you see I've put a very thick rib coming off of that part. We wouldn't call that a uniform wall thickness. That creates that collection of material. It retains heat, and the mechanics are it's going to create an imperfection wherever that mass of material is, and we call it sink. At the least, it's going to be a visual flaw, cosmetic flaw. It could also be a functional flaw. It can cause your part to warp and cause things not to fit. So an important principle is to have any internal features like a rib. And this example has internal features. It has ribs and it also has bosses. Any internal feature you need to have less than the regular nominal wall thickness so that that heat does not collect there and you don't cause problems with your part. So those are three main principles. There's more. And actually, by the way, I teach a class at ACC around parametric 3D modeling in CAD, and also integrated with the class is study of injection molding, designing for injection molded parts. I've compiled a list, and I haven't seen this elsewhere. I'll come back to that. I've compiled this list of basic principles for injection molding. If you follow everything on this list, you're going to come out with a part that a manufacturer won't have any arguments with. Should be able to make it. And many parts, this part included, many parts that I design will hit every single one of those things on the list, and I really do strive to do that. That said, they're guidelines, it's a starting point, and I've also violated every single thing on that list, all of them, sometimes in the same part. So there's ways to do it, but you just, you try not to, because you're making for more difficulty. Yeah, quick question.
What about parting planes?
Okay, I'll talk about that.
Okay.
Let me pull up this other slide. In your 3D modeling software, many of you probably use SolidWorks or Inventor. I just mentioned Creo Parametric. There's going to be a tool in there, among the other tools, to do a draft analysis. You'll really want to do a careful draft analysis on your injection molded parts. And you'll see this one here. I'm going to drop my mic again for a second. You'll see this part here, very much like this part. The red indicates the bottom, everything that's where my hand is. The red indicates that half of the tool, and the green indicates the half of the tool that goes up here, right? So what we're trying to look for in this draft analysis is that everything is green or everything is red. There's another color there, yellow. If something was undrafted, it would show up as yellow, and that's your alarm bell that you need to go back and fix it. So your parting line you're asking about, where the two tools come together, you're going to want to have a sharp line between green and red. And you'll see that one. It could be in a plane, and often is. You can see in this one it actually dips down, I think, where some of those notches are. So that's where the two tools come together.
Let's say, for example, if you stamped it out of metal.
If you stamped it out of metal, you'd be up against a whole nother set of design constraints. Yeah, that would be an option. There's ways to do that. There's another question back here. Okay, let's see. What else we got? Oh yeah. Let's look at our list here. I mentioned 3 principles while we were kind of studying those parts, and we don't have time for an exhaustive study, but let's look. We've got this one here basically is the uniform wall thickness principle, right? Plastic wall thickness should be 1 to 3 millimeters nominal. We have, how about this one, the thinner ribs on the inside? Rib thickness should be 66% or less of the nominal wall thickness. And then also I mentioned here, all vertical features should have draft to allow the part to slip out of the mold. I guess we got a couple minutes. I'll mention a couple of the other ones. Depending on what you have and what features we're talking about, you can use a different sort of draft angle. And then finally, the last one there is you want to avoid very thin sections. For one, you're going to end up with a knife edge in your part, which you don't want, and plus it gets difficult to make the molds for it. I had,
Draft angle, there are draft angles less than 3 degrees, right?
oh, sure. And you'll see a couple of notes down there that it's going to notate that. So I'll just mention real quick that, like Dave mentioned, I have been trying to collect industry knowledge on this topic. And most of, or this comes from what I've been getting together and hoping to come out with this book later in the year. So keep your eye out for that if that's interesting to you. And I think that what I'll do now, have it been about 20 minutes or 25 minutes?
About 15 minutes for questions.
Okay. Yeah, let's take some questions. I think this would be very instructive, and I'm looking forward to hearing what you've got.
What about shutoffs? Good, bad,
Shutoffs?
expensive, cheap?
Okay, shutoffs are, do you want to elaborate on your question? I can talk, but I don't know if I'd be answering your question.
Well, I'm just curious is if they cause any special problems or.
Okay, you can use when the mold has come together, the material will shut off against different surfaces. There's different techniques you can do where part of the mold pierces another part of the mold, and you can create some sort of undercuts using these shutoffs, and it's done every day. There's just specific things you have to do to make sure that it works right.
Right, I
It's
mean,
not-
is there any like special precision that the mold needs?
Okay,
Or?
so for those of you that aren't familiar with shutoffs, the example that we had a very nice top half of the mold and a very nice bottom half of the mold. A shutoff would be a scenario where you have part of the top mold actually coming through the bottom mold in a way. I'm not explaining it that well, but at any rate, the halves of the mold have to slide up against each other. So what you'll do in that scenario is make sure that you have at least 5 degrees of draft between the two, and then you'll reduce the risk of those molds running into each other. And it should
So
be
there's
fine.
no increase in cost or anything?
No, not really.
Okay.
Yeah, it's a great technique to harness. Yes.
What's been your experience with side actions?
Side actions, much and varied. So what he's talking about is actions that will allow you to put undercuts in your plastic part. If you imagine the sandcastle example, if we suck a wall going vertically into the castle and we pull the, you try to avoid undercuts, but if you need an undercut, you put it in, and you put it in right. This case actually has an undercut where we've inserted these magnets here, and so part of the tool will swing under and catch that undercut, and it's just going to be somewhat of an increase in your tool cost, and then you just pay for it and you get good parts. Yes.
When early on, lots of companies worked with 3D printed designs,
Uh-huh.
which is very convenient now. Can you reasonably design that with the intention that you're going to go to injection molding later and
Absolutely.
plan for that and print the 3D drafts and print it out?
Absolutely, and I do it all the time. What you'll want to do is design the 3D parts as if you're designing a plastic part. Yeah, and that's, I recommend it very highly, yeah.
Well, that brings up a question. There are things you can print that you can't mold.
Mhm.
Are there things you can mold that you can't print? Or are,
Wow,
are
great question.
difficult to print?
There probably is. I can't think of one offhand.
Few and far between.
Yeah, that'd be a fundamental exercise. I'm gonna think about
Maybe some
that.
sort of large overhang
The
or
large
something.
overhang, but you can always do.
Yeah,
support
you can
materials.
even do that. Oh, how about this? Very small holes. Very small holes. Hard to do in a 3D print.
And two-shot doesn't work so well either.
Although there's ways you can kind of hack it in. Yes.
So kind of a practical question. You say you teach at ACC,
Uh-huh.
so injection molding. So question with your company here and at ACC, where exactly are you getting your tools manufactured? Are you guys CNCing them yourself, or do you have maybe 2 or 3 suggestions? I do all my CM in China, and I have various injection molders I'll use, but I don't use them a lot, so I'd like to hear 2 or 3 like go-to guys to get your tooling done.
So usually we're working with a client that has that relationship, and I'm going to point you to the people in this room for that.
Speaking of
I wish I had a better answer for you.
seems how you're gonna point us to people in this room, do you mind if we ask who in this room?
Yeah, let's do that. Does somebody have some sort of source for his tooling?
Who all does
Yeah,
business,
excellent point.
tooling vendors in China?
Y'all want to give each other's names right here so you can find each other? Did you see? Yeah, okay.
Maybe everybody, after the meetup, we can kind of post on the forum on the Austin Hardware meetup and say you have, contacts in those areas. And like use the meetup thing.
Yep.
Actually, so along that line, I did a small run, lower volume run in plastic injection mold,
Uh-huh.
and it was because of the dollar, the volume amounts, it was cheaper to do it domestically.
Right?
The mold
Yeah,
was
I've
more
seen that.
expensive, but then if you take in the hassle, shipping, all sorts of, they pay the same amount for plastic in China as we do here.
Yeah.
So, it's something to consider.
Good point.
Does anyone have experience with, or maybe comment on lower cost molds? So like I've heard of aluminum molds and
Yeah.
multi-cavity
I've done
molds and
aluminum
things like
molds.
that.
And it's a trade-off for tool life, right? If you're, especially if your volumes are a little lower and you expect your design to possibly change, aluminum tools can be a great intermediate step. I've done that before. And if they're made correctly, they're reasonably durable, especially if your design is correct.
Yeah. And check out Proto Mold. They actually do have like an online interface where you can get a whole lot of information.
Mold even has some little plastic kind of mold that you can do. I can't think of the name of it offhand, but.
Oh, yeah, it didn't really fit into my presentation, but let it later or whatever. I've got an example of a 3D printed mold here. Is that what you're talking about?
Well, there's some sort of mold that they do that allows you to, produce like, 20 or 100.
Oh, yeah, that's a room temperature vulcanization. That's a cast urethane.
Yeah.
So that could be an option. It's usually a prototyping technique, but you can use it. Cast urethane, it's also called RTB, to produce some 20, 30 parts before your mold degrades. There's a question there in the back.
I heard your comment earlier about the 3D.
About the what?
3D printing.
Oh, yeah,
Vortex. So, like typically, in the past I've used you do a soft tool to work with Vortex and then you do the hard tooling. So are you saying that we can skip the soft tool, just do 3D printing now and then?
I'd say there's cases where definitely, yes, you can do that.
Okay.
And I see some heads nodding. Yeah, I'd say definitely there's cases when you can do that.
And the urethane mold I was discussing works really good when you're doing some engineering iteration.
Yeah, true.
The trick to that one, for those that haven't done it, is you need to size your 3D print slightly differently. Because when you're making that RTD mold, there's some shrinkage involved. And so you need to talk to the guys that are doing the casting, and they can give you the advice on how you need to adjust the size of your part model in order to be able to create a master that will work for that.
Or if you're lucky, they'll
They'll
take
do it
care of
for
that
you these days
in-house.
now. It's a lot easier now.
Yeah.
A lot of them do it now.
Yes.
Okay, for small to medium volume, you've got like a clamshell enclosure. Does it make sense to try and put both halves into the same mold, or is it too fiddly and you're better off making two
oftentimes
separate
it's
molds?
called a family mold, and actually this was done exactly that way. There can be problems in balancing the mold, it's called, but this is a mold for the two top halves as one. They're about the same volume, they're the same wall thickness. You're probably going to be able to get them both to fill properly. So yeah, there's often a case for that, and you would try to do it if it doesn't create other problems.
So how do you decide, is it the asymmetry of the two halves, or, I mean, when do you say, oh, well, it's gonna just be too hard?
Hopefully it's your tooler that decides that.
I know, but I mean.
Wall thickness and volume's got a lot to do with it, because the cooling rates, you paint yourself in a corner if you don't have the cooling rates the same.
Exactly.
You could really jack up your throughput if they've got a.
Oh yeah, yeah. If it takes one like several more seconds to cool than the other one, then you're effectively raising the price of both parts because you're having to wait on it to come out. And
I hadn't heard that one. I thought the problem was the flow.
Also that.
Yeah,
there's more than one
There's a
problem.
whole bunch of things to consider, and one of them being that if you decide to make a change on one, you shut down your production for everything. So you really got to consider whether, what all factors are in play.
And how much cheaper is it to have one mold versus two?
It's noticeably.
Because it's a smaller
It's
mold,
noticeably cheaper, but it just depends.
All right.
Yes.
I will mention, if you do a family mold, it's easier to get a color match.
Oh yeah, there you go. Get a color match with your family mode. There's a question maker.
And for all these rules, Bear also published like a 175-page molding guide. It has awesome color coded pictures and things like that.
Great resource. Did you hear that? Bear, the plastics company, has a good over 100-page design guidelines that you can find online.
And Proto Mold has a little cube that they send to you that's got a really good set of examples of all the different failure modes, or the most common failure modes.
Yeah, there's some really great resources through Protomold, and you should check it out if this is an interesting topic to you. More questions? Yes.
So after you pay like 35 grand, who owns that mold? You get it back from them?
You would want to make sure that you own it, but make sure, because you don't want to assume that you do. Oh, sorry. The question was, after you pay your $3,500 for your tool, who owns it? And I said, you want to make sure that you do, but don't assume that you do. Just make sure that that's in your contract.
Follow up on that. Are the interfaces to the machine standardized?
Not one bit.
So if you, so even if you own the mold and you take it
It
to
is
another
a
manufacturer.
big problem to take the mold you own and put it in another machine. It's a big problem. It can be done.
They, frequently your supplier, if you wanna move it, they're gonna wanna remake it because it's not designed for them.
Yes.
Do you pick the injection point, or does the tooler?
The tooler typically would. I will specify an injection point if I'm have a specific something specific in mind. For example, well, actually, you should have probably veto power or something. For one, you don't want the injection point in a prominently visual area, and there could be some design constraints. I designed recently a bunch of living hinges where I wanted to be sure that I had the flow of material going in a specific direction, so I did insist that the injection point was in a specific place.
What is a living hinge?
A living hinge is when you have a piece of plastic that necks down very thin that will allow the plastic to bend back and forth repeatedly like a hinge without breaking. Yes?
You didn't mention anything about surface finish.
No, I didn't, but I can talk about surface finish.
It was just, when we did our, like, well, I don't know, what surface finish is good?
Okay, let me spend just a couple of minutes talking about surface finish. So, based on the way you want your part to look, you could either have it be glossy, you could have a very light kind of matte finish, or you could have a heavily textured finish. It is more difficult to produce great looking parts with a glossy finish. You'll notice that Apple does, and they do it every day. They spend a lot of money doing it. It's easier to mask subtle irregularities with at least a light texture. One thing to keep in mind is as you add more and more prominent texture, you will require a greater draft angle on your parts.
One more question.
Yes?
No.
Oh, one more question. Okay.
You didn't talk at all about blow molding as a
Oh, right.
way of manufacturing. Is that something you've got experience with?
Certainly. So under the molding heading, there's injection molding, there's a whole bunch of different kinds of molding. One of those would be blow molding, and you'll be using that when you want to have hollow things like bottles. There's a whole art and science to it. Sometimes you're actually injection molding blanks that then go in the blow molding machine, but it can be used for small things like bottles. It can be used for very big old things like tractor parts or various things like that. So you will need to consider, in a slightly different way, you will need to consider some of the similar principles for injection molding like draft, but then other things go out the window as far, you have a lot less control over having a uniform wall thickness and things like that. But yeah, okay, really quick question, then we're
I was just curious, is there like US based molding, or what's the advantage of going overseas versus US? Is there?
Yeah, there certainly is US based molding. In fact, we've got places around here that can mold. It's not often known that much of the plastic molding for the Toyota plant in San Antonio is done in San Antonio and around here, like up in Round Rock. Those are big major contracts, not much of a chance of anybody else getting in there and using those facilities, but there's also kind of like contract manufacturing facilities around here that you can and should consider.
Bailey, that was awesome. Everyone give that. We try to leave at least a half hour at the end. Just the cross talk is awesome. That's what this meetup's all about. So if you didn't get a chance to ask Bailey something, or you wanted to chat more with someone across the aisle, by all means, get some more pizza. Please finish it up.
It's gone.
Oh, well, eat the cardboard boxes then. So, how many of you have heard of ANSYS before? How many of you have used their products before? Awesome. Well, again, another thank you to ANSYS for sponsoring tonight, the leaders in simulation testing products. Tonight we have Todd Venable, who is with ANSYS, and before ANSYS, he was a product designer at National Instruments. And so Todd today works with huge corporations and also small startups. So he's going to bring some of his experience to bear and give him a warm round of applause.
I'll have to admit the blow molding question was actually a little bit of a leeway, a segue into what we do, because one of our software products is called Polyflow, which is used for designing blow molding dies. So anyway, but my name's Todd Venable. I appreciate the warm introduction from David and you guys letting me know how many of you have heard of ANSYS before, and how many of you have used our products. I had a video, but that's okay. It's not connected to the web. I will give you an introduction to ANSYS in under 2 minutes. ANSYS is the largest engineering simulation software company in the world. That's all we do. We were founded in 1970. Our founder was a guy who worked at Westinghouse and was really beginning to use finite element methods and design, and really wanted Westinghouse to be the leader as far as software, using software in the computer to solve these types of engineering problems. Westinghouse said, no, we're not going to do that. And he said, okay, I'm out of here. I'm going to start my own company. And that's how we got started. And slowly we have morphed into going from mechanical FEA to the other physics of simulation. There are 3 primary physics of simulation. There's mechanical/structural, there's thermal and fluids, and then there's electromagnetics. So for the first 30 years, all we did was mechanical. And then we bought a couple companies. One's called Fluent and one was called CFX in the early 2000s. And then in 2008, we bought a company called ANSYS, which brought the electromagnetics into our portfolio. And now we can do complete 3D virtual prototyping with the platform that we have. That is ANSYS in a nutshell. So if you look at, for startups today, right, why do startups need to use simulation? Most importantly, really the costs of the rewards, if you will, of being successful are pretty high. Obviously, there's other things that you have to do besides having good products, but also the costs are pretty high as well. Not so much maybe economically, because there's other ways, lower cost ways to help get customers with social media and even using high performance computing with the cloud and all those things. You can get in at a relatively low entry point cost wise, but for your company the cost is quite high. I mean, you may, if your product flops, you will likely fail. For larger companies, if you're Google and you have a product that flops, you're not going to fail. Does anybody remember Google Wave? Yes. What was it, like IM meets email, sort of? And it was going to be the next biggest thing, and it was a total flop. But they're Google. They have Android. They've introduced other technology that is changing the world, right? So when they have a product that flops, it doesn't matter. We like to say that every product that you make is a promise. Obviously, it's a promise to your customers that it's going to work under the conditions you say it's going to work. But for startups, there's an additional group of people that it's a promise to. Can anybody identify who those people are? They're your investors. If you show them a product that fails, you're in a lot of trouble. So going back to what Bailey was talking about, he showed a timeline of developing a product and getting something injection molded. He showed a $35,000 tooling for this nice little box here. Well, one of the steps after that, I don't know if you guys saw, was adjust design. So most of us in this room are not going to spend $35,000 on tooling. It doesn't make sense because we're not going to build hundreds of thousands of these guys. But if you spend $3,000, $4,000, $5,000, $10,000 on tooling, and you have to adjust your design later because you didn't adequately test before that product was designed, you're going to have some explaining to do to your investors. And you're not going to get to market as quickly as your competitor. So the need to do full simulation is incredibly high, I think, across the entire industry, and ANSYS is a growing company as a result of that need. But the need for startups is even more critical. And the message really that we have at ANSYS, and again, I don't want this to be too salesy, it's really more driven towards simulation, and there's other simulation companies out there. I will talk about the ANSYS startup program as we move on. But the approach that we take is called simulation-driven product development. And the most innovative companies in the world are taking this approach. One of the first ones to take this approach is SpaceX. So we sell to SpaceX. We also sell to Firefly Space Systems, if you're familiar with them in Cedar Park. And we also sell to the traditional aerospace companies that are deeply rooted more in the military space, Raytheon, Northrop Grumman, Boeing, Lockheed Martin, and the like. SpaceX is about 10 years old as far as how long they have been designing and developing spacecraft. I think they were founded in 2002, so they didn't really do any design for a while. So in 10 years, SpaceX has been able to reduce the cost of putting a pound of payload into space by 50%. And they're not done. Their goal is to reduce it by 90%. So when we meet with some of these bigger aerospace companies that have been around for a long time that are traditionally rooted in the military, and we say, why do you think that is that SpaceX has done that? Of course, they think it's because they use ANSYS, and that's not true. They do use ANSYS, but they also use some of our competitors' tools. What SpaceX has done is they say that they want to be 85% of the way done with their design, and the way that they measure that is through engineering change orders. 85% of their ECOs need to happen before anything is built. And the remaining 15 will happen after build. And these are that includes embedded software, that includes every component on that spacecraft. So they've been able to adopt simulation-driven product development by simulating as early as possible in the process. Because those product designs and those adjustments that you need to make are costly after something is built. And that really can't happen in our line of work. So if you look at the traditional product development process, it's very linear. This is the process that a lot of the traditional aerospace giants tend to follow. You design a product, you build it, you do some testing, something goes wrong, now we'll open our ANSYS and figure out why it went wrong after they've built so much of it, and then you make a design change and you go back through and around you go. A lot of our customers, unfortunately, still use us in this traditional methodology. But what companies like SpaceX have done is made simulation a critical part of the conceptual design phase and the detailed design phase before prototyping ever happens. This is an article from Forbes magazine by a gentleman who's I didn't know who he was, so I looked him up on LinkedIn. He's a guy who's a founder of a startup in Philadelphia. And it's all about why and how simulation is the future of innovation. And I think that's certainly true for hardware startups, but he's actually a startup founder that's focusing on e-commerce and traditional stores, brick and mortar stores, and he's using simulation to look at the flow of customers through a store to try to help companies and retailers to better position products so that they catch your eye and you buy them. They're using simulation for that. This article also actually talks about the 2012 presidential election, and I'm not going to talk politics, don't worry, but they talked about how one thing that was critical to President Obama's campaign was to run a lot of different simulation models to see different results, up to 62,000 a night. So if you Google why the future of innovation is simulation, read this article, it's very interesting. He had a quote I loved. The point isn't to be right, but to be less wrong over time. Sorry, that's a typo. My apologies. The point is to be less wrong over time. So going into, I wanted to borrow Bailey's box here. Going into how simulation can be used for something like this. He talked about it for an implantable device, so let's pretend this is Medtronic, who's designing this box. Some of the things that are possible with simulation, traditionally, most people use simulation. They have their design, they consider their design done. Hey, I'm going to bring it into simulation, I'm going to set up my boundary conditions, and I'm going to get a result. Right? That's the traditional method. But another thing you can do with simulation, and why really innovation is dependent on simulation, is ask yourself, what if? What if I choose a different material? What if I change something about this design? How do I get to the optimal design? So I'll give you an example of how this might be used. Let's say you're using Creo or SolidWorks or CATIA or Autodesk, any of those other tools for your CAD. You design this in CAD. You could take it into our ANSYS mechanical product, and all of the native properties are going to come in with it. You can set up on as many of these faces as you want to parameters, and that parameter could be wall thickness. Let's say you want to design this box to minimize the material as much as possible, but to make sure that if a 6'10" surgeon drops it from the middle of his waist, that it's not going to break. Okay? So using ANSYS Mechanical, you can do what we call an explicit analysis. It's a drop test, if you will, from varying angles where you vary the width of your wall thickness, let's say between 1 and 3 millimeters, for instance, for the purpose of manufacturing. And then you can add in a factor of safety after that if you want to. So you can determine what the optimal design is to minimize for material costs. You can even change different materials if you want to, including cost, to factor that in as a parameter, to build the lowest cost box you possibly can. Those are the kind of things that are possible with simulation and what some of the larger, more most innovative companies in the world are doing. Further, this is a slide actually that was given to us by one of our larger customers. Going back 10 years ago, simulation was largely considered to be, particularly multi-physics simulation as we call it, was considered to be a little bit of black magic. A lot of people didn't trust your results. There was still very much a mentality of build it and break it. And that's true even today, right? If we say roughly in 2015, a little bit later, you're going from maybe 5% of engineers using simulation in 2005 to only less than 20 still. So simulation is still very much in its infancy. This was shown to us by a customer I mentioned before, and they basically said, hey, in 2020 all of our engineers are going to be using simulation, so we need to work with you guys on a model that's sustainable for our company, that's not going to totally break the bank and those kind of things. So we've used it a lot just to demonstrate how simulation has grown in recent years. So this brings me to the startup's problem, right? It's really a chicken and the egg problem. And you guys face this problem every day. You need to use simulation. You need to be doing validation in software long before your product is prototyped. But you don't have the money to pay for our high-end, nicely, very expensive simulation tools. And that's where ANSYS came up with the ANSYS Startup Program. So really the goal of the Startup Program is to get in at the ground level with you, to help enable your innovation early on, to take a small amount of funding that you may have and help you get more funding, and to make you be successful, at least from a technical perspective, so that you can get to market and take advantage of ANSYS technology in order to do that. That's the goal of the ANSYS Startup Program. Let me share with you a success story that we had. A company in Silicon Valley is called Nebia. Have you guys ever heard of these guys? So they build the world's most energy efficient or water efficient shower head. There's a lot of waste that goes on in showers in hotels specifically. At your house, 50%, I think a full, maybe even more, 50% though, I think at least of your water bill is consumed in your bathroom. So they're trying to help mitigate this. So their challenge was really interesting because they want to, anybody can build a shower head that's going to reduce flow, but the challenge is doing it in such a way that when it touches you, it doesn't feel like a mister. You go to, I was going to say Carlos and Charlie's, but they closed. You go to another place on the lake in the middle of the summer and you got these misters going, they feel so nice, they're nice and cool. You don't want to feel that way in the shower. You want to feel warm water. So these little tiny droplets that come out, the challenge is that the convective heat transfer of these coming down is because these particles are so small, they get really cold in that 2 feet of space in between your shower head and the top of your head. So they had to run through a ton of different test cases because they couldn't build a bunch of different prototypes. They ended up building a lot of prototypes, but they built about half as many as they normally would have because they used our computational fluid dynamics tool to look at the varying cases to see what's the flow going to look like, what's the temperature at the top going to be, and what's the temperature at the bottom going to be to get to their optimal design. So this is a really, really cool one that we're excited about. The ANSYS Startup Program launched in 2015 in Q3. What we've done is we've created 2 specific product bundles, and I'll share with you the eligibility criteria in a moment. There are specific terms and conditions associated with that, and there's really we're not doing a lot of marketing. A lot of the marketing is just coming from individuals such as myself who are meeting with you guys to let you guys know about it. Some of the startup criteria, first of all, obviously we got to believe you have a solid business model. Some of these are hard requirements and some of them are not. One of the hard requirements is that you're a private company. You can't be publicly traded. This doesn't apply to consultants. We do other types of deals with consultants. Talk to me later on if you're interested in that. One of the software requirements is 5 years old. We're obviously not interested in working with a startup that's been a startup for 20 years. And then $1 million or less in revenue, that's another relatively soft requirement as well. So, before I did this presentation, I had never seen the bottom requirement there. There are some people that only have 2-year degrees or even no degree that use our software very successfully. So that's not at all a hard requirement. The bundles themselves are broken into structural and fluids and then electromagnetics. Some startups need both. I've sold to a startup that required both. So the structural and fluids bundle includes what you see here, and I could go into these different products, but I'm not going to bore you with them. One important thing to note, each bundle contains 2 solver licenses of each of these products. So if you're doing structural, you need to do a lot of structural analysis. Maybe there's you and one other person in your company, and you both need to do it all the time. That's included in the bundle. It's not a single license, and the licenses are floating, so they're not node locked or they're not tied to a specific user. They are totally floating. The way it is priced, it's $5,000 per bundle per year. It's an annual lease, is the way it is set up. The startups I've worked with, the ones who have seed funding, $5,000 a year is a very reasonable cost for most of them. If you are getting in totally at the ground level and you want to talk conceptual things with us, come and talk to me. By the way, I left a stack of business cards back where the pizza used to be. So feel free to grab a card on the way out if you have any questions, and I'll be here for a while. I just realized about 80% of the way into my presentation that I forgot to introduce my area director who was with me. Sorry, John. This is John Condon right over there. Don't put this on my performance review. My apologies. The only other thing that we say as far as the pricing, there are special terms and conditions. Basically, if we ask you for a case study, that you would be willing to give us a case study. That's pretty much the only thing that goes beyond the standard terms and conditions. You can use the software for commercial use, for whatever you want to. It belongs to you. Hopefully, we get to work with Jeremiah here and use the tools to store your simulation files on the web. That would be pretty cool. And then the last thing I want to mention as well is technical support. So our products are complex. Customers are building their own extremely complex products using our tools. So customer support is going to always be critical. So ANSYS takes this very seriously. We have more applications engineers on staff than we do salespeople. We have an office on the corner of 360 and Las Cimas Parkway, just by Bee Cave Road in Westlake. We've got 50 people in that office. I'm one of 3 salespeople. We have several application engineers, way more than 3. We also do some new product development and have some marketing there as well. So we've got a strong local presence with application engineers that have been given full leeway and freedom to support our startups just like they would a large company. In fact, when you purchase the startup bundle, so $5K per bundle, so you purchase, let's say you only do the structural bundle, what you're really paying for is the support that you're getting. We're basically giving you the software for free. You're just getting access. In addition to that, you're getting access to one of our local application engineers right here in Austin to help you with the tools and to help you be successful. So yes, question.
Your software, you're saying a lot of it's focused on optimizing parameters, based on parameters or constraints. Do you ever see a day where your product is totally constrained and parameterized and the software designs it? So, for example, the shower head. Right? You don't place the holes, you say, I need this area to be warm.
Right.
And these are all the parameters.
Basically like simulation.
Automation.
Sort of like how they're teaching robots how to code, are they going to teach computers how to use simulation?
You define a bicycle and say a person has to.
Maybe it'd be something like a Monte Carlo simulation where it'd be a genetic algorithm where it would simulate and then change a parameter, simulate again until it zeroed in.
So I don't think so. There's still a good amount of engineering expertise that has to be done on the design side. One reason why, beyond that challenge, another challenge is just HPC capacity, right? So what I mentioned before, as far as optimizing the design of a component like this, that's a tool that we have called Design Explorer, and in the CAE world, you'll hear design exploration used as a term for what I just mentioned. That can be done completely, and in fact, you'll see that a couple of the tools that we have as part of the startup bundle are HPC packs to do multi-threading on up to 32. It's 2 packs, so it's up to 32 cores. To do that level of simulation, to get down to, hey, what's my detailed design going to be? The amount of boundary conditions are huge, the amount of parameters are huge, and the more parameters that you use, I mean, HPC cost has been going down, which is good for companies like ANSYS and customers like you who need to take advantage of that, but I don't think we're anywhere near the point where we would have that kind of computational capability. That's just my opinion.
There's some little snippets in that direction related to like 3D printing, where people are looking at the minimal material required to maintain the structural integrity.
Right, and that's
So that's kind of
what we're doing.
where the genesis of my question was. I was starting to think of, 3D printed bicycle frames or houses that are 3D printed. You start getting, shapes that are designed by computers to optimize the structure.
Right.
They kind of look at the stress strain analysis and then remove the material that's not creating structural integrity, or doing a minimal amount of it and offset the weight.
Question in the back, I think?
Yes, for your simulation software, what programming language do you use and why?
We use Python. As far as automation, we say programming to build it or to automate the environment. What do you mean?
The software that you provide, it does these simulations.
Right.
What do you use? What language do you use for that?
It is Python.
Okay.
And the reason why the automation is in Python is because the software itself is written in Python. So obviously it's not open source, so there's no access to that code. There are open source tools out there. To use them, you're going to spend a lot more than $5,000 just getting them to work, because you have to build a GUI in front of them.
So Maxwell is written in Python, is what you're saying?
I believe all of our licenses are written in Python, but I can follow up with you and we can chat more about it. What may I ask? What's driving that question?
I was just curious what
Okay.
you guys used and
Okay.
the reason for it.
Yeah. So and then we do. You can do a lot of automation. So there's companies. Some of the most innovative companies in the world. A point-and-click environment only gets you so far. If you're doing the same types of analysis over and over again, you really got to automate, and that's done through Python. Is how we do that as well.
So,
Yes.
so is there an actual Python API that you can use to communicate?
There
with
is
the
indeed.
interface?
Yeah. So you could call it from anything you want to,
Okay.
and so you can absolutely do that.
So you could run this on a server and then put it behind some other front end.
Correct. Yep. So there's there's a cost benefit associated with doing that oftentimes, but yes, you can call. There's a full Python API, both for automating the environment as well as adding your own customization, where you have basically some of our customers, connector company. This has been published on the web. I can tell you who it is. It's Molex, where they have a standardized workflow where when they don't open ANSYS, they open up their own GUI and they sort of configure their analysis based on a couple button clicks the way they want to do it, and it calls the solver under the hood, and that's all through the Python API. Yeah.
I know this is going to vary a lot, but what is the computational requirement for a typical
That's an
simulation?
outstanding question. So the more capability you have, the faster your simulation's going to run. Wow, that was super smart of me to say that. So by default, with the exception of mechanical will run by default on 2 cores. Every other tool, including CFD and electromagnetics, will run on 1 core. Now, we have HPC packs as part of the startup bundle, so you will get access to up to 32 cores. Standard, what we see, our AEs use the recommended laptop. It's a Dell that has 8 cores on it and 64 gigs of RAM, and that gives them solid performance. You don't have to go up that far, but that's typically what they do. And the types of simulations they run, the 64 gigs of RAM they run into a wall with that sometimes. Now, we also have what we call the ANSYS Enterprise Cloud, which is not part of this because it runs on the Amazon cloud. So you have to have an Amazon account in order to use it. If you have an Amazon account already, fantastic, you can take advantage of it. And what the Amazon, the ANSYS Enterprise Cloud does, I mean, you can outsource all of your simulations to the cloud if you want to, where you basically just have the GUI installed on your laptop or whatever device you're running it on, and then you can connect to the cloud and run on as much as you want to, assuming you have licenses for it. And then, then obviously Amazon bills you kind of on a per, I don't know how exactly they charge you, but the more you use, the more you pay.
So like that shower head fluid dynamics simulation, what's the order of magnitude? Seconds, minutes, hours, days?
CFD is very complex. There's no way of getting around it. I mean, you have, for example, the mechanical, I already gave the box back to Bailey, but the mechanical example I mentioned there, you would do a mesh of just that box. When you're doing a fluid analysis, you do a mesh around everything, right? So it's a very complex, you're running a lot more computations than you would on a mechanical FEA. With 32, if using all 32 cores and you have plenty of RAM, simulations can run 10 to 30 minutes sometimes. And if you're doing something that's really complex, it can still run a few hours. And if you don't have a lot of HPC capability, or you're not using a decent machine, a lot of engineers I know will click run on their simulation before they go home, and then they'll come back in the morning and it'll be done. It varies. It's something that varies quite a bit. Any other questions? Yes.
So I'm wondering if ANSYS would be a good tool for the following situation. If you have an instrument, maybe a semiconductor instrument, and you have electrical boards, you have pneumatic systems, electrical systems, and maybe some RF thrown in there, would it be able to model a system like that with a bunch of these discrete systems, third-party pieces?
Great question. We didn't go into system modeling, but absolutely. So ANSYS has as part of the startup package for electromagnetics, that's not Simplore Basic, it's Simplore Advanced is what's in there. Simplore is our system level simulation tool. So you can model not only the varying components, all the components you mentioned, but even down to embedded software. Has anybody heard of the concept of a digital twin? GE is talking about it all the time. They're really the only ones. But you can create a digital twin as a full virtual prototype that includes embedded software. And yeah, you can get down to that level.
So could you do like heat and airflow and electrical interference?
Correct.
Those kind of things?
So you would have, it's a complex, there's a lot of different simulations that would need to be run, but the digital twin includes all of the physical models and all the physical simulations, coupled with the varying system components together, the various, obviously you may have an output from one device that's an input to something else, right, if they're connected to each other. So the full communication between all those different components, as well as embedded software. So it handles both the physical as well as all the boundary conditions that these systems collectively share. So, great question.
Thank you.
Yeah. Yes?
So I was wondering when you were saying you're talking about using cores, that kind of surprised me because you were saying that your compute bound without using GPUs, whereas a modern GPU is in the teraflop range now.
Right.
So I don't know if you're aware of this, but I'm on the site right now, and I don't know what version you guys are up to, but NVIDIA and ANSYS is partnered now, and I'm looking at the simulation speed ups, and you're getting 300 to 400% speed up by having an NVIDIA card in there. So that just completely changes. You don't need a multi-core processor. You can just use.
That's a great question, and so yes.
I don't know how old this is, but it looks pretty new.
It is. That is absolutely correct. And an HPC pack I mentioned is so the reason why I said you have two HPC packs that gives you 32 cores is because when you add a second pack, you get a 4x multiplier. So it starts out as 8, and then you add a second one, and it gives you 32. An HPC pack will give you either one core or one GPU. Okay. So it will absolutely work on GPUs. Now, some of our solvers are optimized for GPUs, and some of them are not. So for all of them, you get significant speed upgrades by using cores. for some of them, and I don't know which ones off the top of my head, you will get better performance by using a GPU. Some of them you're much better off using an extra core.
Right, and are you currently agnostic to GPU vendor? Are you using OpenCL as an interim, or right now are you just partnered with NVIDIA CUDA core, so you're talking at that level, so what's the deal with that?
Right now, I believe we're only talking NVIDIA for now, just based on just all the IP under the hood and everything. We had to kind of pick a pony, I think, initially. So we'll see if that expands, but for now, it's just NVIDIA. Any other questions? Yes.
I guess really like for magnetics, do you have any interesting use cases for, like, you have traces that are meant to carry so much current, and you know, different crystals, circuit board, follow up, like what kind of, can you import like sort of popular boards?
Yes, good question. So from an MCAD standpoint, we are totally CAD agnostic, both from an ECAD or an MCAD standpoint. So for MCAD, Creo, SolidWorks, Inventor, AutoCAD, whatever. From an ECAD standpoint, Cadence, Mentor, Altium, whatever. You can bring in all those files natively, and it's fully supported. So typically at the board level, if I understand what board level simulation is largely kind of signal integrity, crosstalk, S parameters, all that sort of stuff. That's what, we've got a full board tool called SI Wave, which is a signal integrity tool, as well as that's a 2.5D solver, and then we have a full 3D full wave solver that's called HFSS. So that's used a lot for antenna design. So HFSS is one of our growing products. With IoT and everything, there's antenna going on everything. So a lot of antenna designers out there, and they're validating those designs with HFSS.
I think you're getting close to these speakers here, is your problem.
Is that what I'm doing? Thank you. I'll stand back.
Engineer in the room.
It's just, well, you guys are you're drawing me in over here. What can I say? Go ahead, your question?
So in magnetics, so do you model or have a way to simulate just magnetics in an open space with different kinds of interference?
Yes.
Background?
Yes. Yeah.
Permanent magnet or ferrous materials or
Yes.
background geomagnetics
Yes.
and all that?
And if my EM guy was not on vacation, he would be here today, and he'd be able to answer all of your technical questions related to that. So I'm happy to set up that discussion. Yeah, fully. In the back, yeah.
So does this allow you to plug in like agency requirements like CE, FCC? If I said I want to validate this design for certain
Like EMI, EMC.
EMI-MC, but specific ones, like if I pick like 61300.21.
Yes, we have a workflow for EMI, EMC, and like CE, those types of standards. We do have workflows for that. I don't know how vertical they are, where you could just basically click a button that this is exactly what you're looking for. Now, going to that question, really, and I'm working with a couple of customers now that are looking at, they've been spending so much, these are large companies in Austin, if I told you who they are, you'd know. Large companies in Austin that are having major CE compliance problems. And when they come to me and say, hey, we're looking at a solution to get past CE, software solution, because we're just spending so much money and it's taken us so long. It's sort of like if you had a leak in your house and you went to a pump shop and you say, you know what, I've got a leak in my house, I need a really good pump. Rather than fixing the leak, yes, you need a pump, and yes, we can help with that. But in reality, those issues come up because of signal integrity. And doing really high fidelity signal integrity, and it doesn't have to take a long time, at the board level, will solve 95% of CE issues. And that's where a board level tool like SI Wave comes into play. So yes, we have a workflow for it. I don't know how vertical it is there, but you can absolutely use SI Wave for that. But more importantly, it is a tool to help you get solid signal and power integrity so that you can avoid those issues to begin with. Yes?
When you're talking about doing something as advanced as the digital twin type of modeling, how do you interface to the software systems, development systems, debugging systems, especially when it comes to the embedded space?
So that's a very good question. So the way, and I'll answer it the best way I know how, and if I am not hitting on the right points, I will make sure to get you in touch with somebody who does. The main IoT platforms that exist today are one's from PTC called ThingWorks, and one's from GE called Predix. So the way that the digital twin there works is essentially with IoT, right? Everyone wants to do predictive maintenance, right? You want to be able to get data back and be able to, more important, anybody can get data in. And so that's why everyone's talking about big data analytics and all this stuff, right? You want to be able to decode that data to determine when is something going to fail in the future. Well, what the digital twin enables you to do is to optimize, to not only answer that question, but to optimize the design of your future products and the design of your future systems so that you can make everything run much more efficiently. So the way that that works is you have, let's say a large system with a few pumps. I'll use some simple examples here. You have the physical model of that pump running in ANSYS, and then you have a connection between either a GE Predix or a ThingWorks platform where you have data coming in and you've got data coming out, measurements and control essentially. You've got the control as essentially boundary conditions into your model that you're running in real time along with the actual physical environment. And then you have physical measurements as well that are serving as inputs into whatever comes after that. And that is all done in real time.
That's more of an operational thing, though.
Correct.
Is there anything that happens more on the design side with that kind of simulation? Let me give you an example. Let's say, maybe the best example if you're picking something out of here. Let's say I'm driving an Ethernet interface, okay? And normally it's 10100, but I want to see what happens if I decide to upgrade that and crank it up to gigabit speeds. Do I have problems now with my traces on my circuit board? Is there any way that we can look at that and tie that back in with the software and the signals that would be
Right.
driven
Yeah.
to drive that simulation?
Sure. So I mean, you could set that up as a boundary condition in your board level simulation.
Okay.
Based on what your data rate is, right? You set up that. You set up your data rate. You can set up your frequency, whatever it may be. As far as embedded software with the digital twin, you can. It's the debugging aspects are a lot easier on the physical models than they are on embedded software, obviously, because it can be so lengthy and complex. So there's really not a way to, I mean, you can diagnose so many problems as being embedded software problems, but going in and debugging some of those elements, or but what you certainly can do is you can certainly change your embedded software and then run your digital twin and see what that change is going to be. Actually doing debugging, that's not something that ANSYS does.
Okay.
Although we do.
I was wondering if you had hooks in. You said you had hooks into some of the other
Right.
CAD systems. I was wondering if you have hooks into like IAR or something like that.
Well, we may for we do have a model-based systems engineering tool called SCADE. It's an embedded, it competes with Simulink. And what SCADE does is you build your models, looks a lot like Simulink, and it actually spits out certifiable C code to like DO standards or these IEC standards. So there's actually 10 million lines of code running on the Airbus A380 that's based on SCADE. I'm not a SCADE expert, so SCADE I'm sure has debugging tools within it. So you would be able to do something like that. But yeah, great question. Anything else? Okay, well, thank you so much. I've got the cards in the back. I look forward to talking to you.
Thanks, Todd. At this point, towards the end of the meetup now, kind of just open things up. If you would like to introduce yourself, if you're a long-time hardware meetup participant, you just want to introduce your services or company, that's okay too. So just show hands and we'll take some turns. Zubi.
Good evening, everyone. I'm a software guy, so all of that stuff you guys are talking about just way over my head. A little bit about myself. In the 90s, I wanted to be a doctor, and I joined the military to help pay for it. But like most immigrants, I was a few zeros short of the cost of education. And then I became legally blind. I was diagnosed with macular degeneration. So I ended up studying engineering. So I think there are about 100 people here, because I've been here many times, but if I don't recognize you downstairs, I'm severely visually impaired, so I don't see very well. But with my training as an engineer and my passion for medicine and solving problems, today I'm trying to solve issues that are faced by people like myself. And there are probably 200 plus million of us worldwide. And I guarantee you run into us, every day in your life, but you just don't know, just like you can tell that I can see very well. Think and Zoom is my company. You can see, visit thinkandzoom.com for a demo of our product. Our first foray is using EEG. I don't know how many of you know EEG, but it's called electroencephalogram. It reads your brain waves. So we came up with an innovative way that detects whenever you're struggling to see, and it magnifies whatever you're looking at using Google Glass. So that's the extent of my hardware knowledge. Okay. Why did I really come here? I came here because I just wanted to interact with some people. I'm looking for co-founders. I'm looking for thinkers like David, people who are just very knowledgeable with all this stuff you guys are talking about. I would like to do some local prototypes, and then I'm interfacing with a lot of low vision entities, in the Austin community, like the School for the Blind. So I want things that I could show to them and start validating the concept, and hopefully we can give them a product in, let's say, 12 to 18 months. That's it. Thank you.
Could you spell your website?
Sure. Thinkandzoom.com. Think and Zoom.
N like
think and like
and
yeah.
Thinkandzoom.com.
Thank you.
Good evening. My name is Mike Beal. I first want to thank the presenters. Great job, great information. Appreciate your time and sharing. I had a customer of mine refer me to this group, and he said, Mike, you got to go to this because the gap between prototype or idea and production is what you fill. Okay? What I do is I help entrepreneurs like you transform ideas into revenue. Okay? We offer anywhere from design to mold making to injection molding capabilities, okay, from a company that's got my name on it in China. So I'm not a guy that found a guy, and I'm not found these guys on Alibaba, okay? I've been doing this for 15 years, and we built this company up, and it's all about helping guys like you take your idea into the market. I appreciate the idea about somebody rolling the dice in China. It ended badly. I had a customer referred to me who said, hey Mike, I got an idea. I quit my job, it's going well, and then my manufacturer in China disappeared. So after I gave him a clean pair of underwear, I said, dude, I think I can help you out. And he said, oh, by the way, I don't have any of the designs. We redesigned his whole product, got him up and running, and he is happily self-employed right now. So my model is, you own the IP. I'll give you ideas and suggestions, and if you want to incorporate those, incorporate them. I want to make your product win in the marketplace, and you own that. Because if you win and you sell a bazillion of these, I get to make a bazillion of them, okay? So we're on the same team. And I can probably do it. I think I've got the best mold making capabilities over there, and I can probably do a lot of that stuff for about half of what you've been quoted. So if you're a hardware guy and you have a need and you think there's a fit, I'll give you a card, or go to LinkedIn and search Mike Beal, B as in boy, E-A-L, and pull up my profile and contact information. I'd love to talk to you. So thank you very much for your time.
Hi everybody, I'm Kara over here, and I work for a local contract manufacturer and integrator in Round Rock. And so I know a lot of you folks are developing products, and that you're probably going to be looking into going to production soon. So if you're interested in that, please come see me. You'll get lots of personal attention, and sorry, I don't have much of a voice. But yeah, come see me after the meeting, and I'd be glad to talk to you about your product.
Could you just give a quick rundown of the services you offer?
Or the name of the company?
Yeah, Spectra Dynamics. We've actually done business with some folks in this room. But, you know, we work in a variety of different industries. We've done work in medical, flight simulation. We do boards, cables, kitting and fulfillment.
Mass spectrometers.
Yeah, mass spectrometers, thank you.
Consumer electronics?
Some, but we are a small business, so we work more of our specialty is, you know, getting startups off the ground, helping them make their product more manufacturing friendly, just helping them get off the ground basically. So like I said, I'd be really glad to work with you. Come see me, or Ben in the back, he's our production manager.
I've worked with Spectra for a number of years.
So I really didn't want to put this thing in my hand. I'm not much of a speaker, but I think I know a few guys in here. Anybody ever heard of Avnet Electronics? My name's Pam Sylvester. I'm with Avnet. I've been with them since forever. This is my 38th year in the industry. I specialize in just startup accounts. That's all I do. We call it CET. It's a customer expansion team. Is any of my competitors in here? Future, Arrow? No? Good. I want to make you guys aware of a website that you might want to visit. We've set it up just for entrepreneurs, engineers, you know, startup accounts. It's www.makersource.io. If you're interested, or if you're in doing work for, you specialize in something or whatever, there's a form you fill out in there, and what we're doing is we're connecting people like yourselves to people all over the country. So anybody that works with Avnet or does anything will have access to this website and can find your information and contact you. So we'll be here in a few weeks or months, whatever it is, to talk about a few things that Avnet does. But if anybody wants one of my cards, I'm sitting right over there. Glad to give it to you. And I know a few people in here. Oh my God, it's good to see you.
Anyone else? Andre?
No, I'm good.
Okay. Sure.
I'm working on a project here, although actually I'm working on numerous projects. You hear me all right?
Name. Your name?
Okay. Oh, my name's Kenneth Alter, Alternative Concepts and Designs. And one of the smaller projects I'm working on is next generation past the smartphone, which should only have a market cap considerably better than the iPhone. That's one of my smaller projects.
What's your website? Or your email?
AlternativeConceptsAndDesigns.com or acnd.com.
acnd.com. Anyone else? Oh.
Hi, thanks for having this, David, and thank you for everybody that came. I'm a LabVIEW developer. I've worked as a technician and software and stuff like that. I just want to try to get into the maker thing, and I don't know, maybe this crowd is a little more industrial, higher level, so I just want to introduce myself and avail myself for BS sessions or whatever you like about it, software and hardware, like program hardware.
What's your name?
Oh, my name's Mark. I'll try to make my face friendly. The one thing I would say is if people could put kind of their specialties on their profiles, because the people that did have it, it was easy to go, okay, I want to try to meet that person or whatever. So just
last name?
he knows me. He's ribbing me. My name's Ramsdale. It's English, so but Mark. So I hope to be here more often. Thank
Mark, do you work down at Orange Co-working?
you. No, I don't.
Oh, you don't?
No.
I thought I heard your name.
Maybe my doppelganger.
Oh.
Hi, my name is Jesse Younger, Texas A&M class 2008, graduated mechanical engineering. About 8 months ago, I quit my cushy corporate job and started my own little engineering consulting firm. And by little, I mean little. It's me, another engineer, and a part-time drafter. So I'm a startup as well. We just moved to Austin yesterday from Houston. Looking to get some clientele here in the area, so my wife doesn't have to go back to work in December. She's on maternity leave right now. We have a 2-month-old, so pressure's on.
What do you do, Joe?
So right now I have a client in Houston. It's a LED lighting startup. So linear LEDs, aluminum extrusions, sheet metal parts, plastic extrusions. When I was in school, I worked at the mechanical engineering machine shop, so very familiar with machining, welding, and your typical manufacturing practices. Injection molding I'm not familiar with, but I'm going to do some research after this. Maybe talk to you, Bailey. So yeah, if you're interested in talking or just getting to know me more, I'll be up here. I'll be here afterwards.
Oh, you're an electrical engineer?
A mechanical.
Mechanical.
Yes, sir. And I also did some work. I'm here because of Utz Baldwin. I did some consulting with them. They're the plum light switch, UV dimmer switch. So he told me to come here, and I'm glad I did. So,
Welcome to Austin.
yeah, thank you.
Great. Guys, thanks again. Here till 8:30 until I'll kick you out. One thing I'll ask before we wrap up and just network a little bit is please just clean up your area so me and the Capital Factory staff don't have to. And hey, thanks again for showing up. Appreciate it. Thanks to ANSYS and our speakers as well. Thank you.
Yes, sir.
David on the meetup.com. Yeah, just send him a private message. Oh, really? Yeah, it's pretty easy. Yeah.
I've been kind of interested in that. Is indoor growing actually a future of the farm?
100% of the future. In fact, if you look up, if you search on Google like DARPA rise and Ebola virus, it was actually farmed in a group of farms. Like the protein that carries the virus was farmed I attempted to teach myself Well, there you go, right?
I know you guys just want to say hi. I annoyed you a couple times when I first signed up. Michael Kerwick. I'm just trying to take any avenue. You did annoy me. No, I know. You just, yeah, I was kind of like, thanks for coming. Yeah, yeah. So, hopefully you come up next. I'll give you a hard time. Yeah, I've been coming to, I missed the last one. I was out of town with these, but I've been coming to
Yes, this is your first one. Any suggestions or if you think about it, it'd be great.
Yeah, no, I mean, you know, I guess.
Oh, you really did wear it. I did. At least, why did you come up?
You know, I almost did, and I thought, well, I don't know, maybe next time. Yeah, sort of. But then it's sort of, you know, I'm looking to find other people. This is a little bit just really kind of love it too.
Any of these, as you saw, it's the first time. Most over half of them
Yeah. It's like
a co-op. Yeah, it's just it's like
not too much, but maybe. I guess a couple of people like, oh, when you do get buttons, I'm ready to.
Well, it's hard. I think co-founder business is probably good. In this group, it's hard. I think a lot of these entrepreneurs don't come here because they're too busy doing it.
Yeah.
And so getting those connections, it is hard. My day job is cybersecurity. Hardware professional.
Okay.
I inherited this group about a year and a half ago. And it's just a small group.
Yeah.
And it's again, passion, and it's a way to impact as well. By day, cybersecurity on
So you do like maker stuff in terms of like satisfy that?
I saw a computer science major, hardware tinker. I invested in now just hope they do well and step back. It's about the scenario red is what I wanted to really see more of in town. That's why I was asked to kind of